Here on my page, I have an equation, x plus 3 equals 5. I'm simply asking you, what adds to 3 to make 5? You can probably do it in your head, and that's exactly what we want for now, because we're going to start in a comfortable place to build the foundations needed for the more complex math, including positive and negative numbers. Now, when I look at this equation, we've already established that you can do this in your head. I want to know what plus 3 equals 5. Now, what is this mystery number? Well, we know it's 2. That also means that this side, 2 plus 3 equals 5, that each side of the equation is equal to the other side of the equation. Now, in order for me to really figure out what this mystery number is, I need to get it by itself. What does x equal? There's a couple ways you could do that, but we're going to start today by modeling it with algebra tiles. I'm going to build the equation with a model. So I have an x, and that's the x that I have right here. I'm going to add to it 3 ones because that's what I'm looking for, 2 and 3. I also have an equal sign, dragging that in, and then I have 5 more ones, 2, 3, 4, and 5. And I'm moving them around for no other reason than I'm moving them around. Now notice that when I built this, that the color red over here on the left is the same color as the box with the equation. If I pull one of these little guys out, notice they're not color coded. That's going to help you know when you're on the right track. Now we know that we're going to try to get x by itself. We want to know what x equals. In our model, we don't have x by itself. So we need to add something and change this equation without changing its equivalency. And how can we do that? Well, we could add 1 to the side and notice that it's not equivalent anymore. But if we do the same thing to the other side, notice it is still equivalent. And when we think about that, we're like, oh, well, why is that still equivalent? Well, now we have x plus 4 equals 6. That's not getting our x by itself, but it is equivalent. That's because the value of 2 plus 4 equals 6, just like the value of 2 plus 3 equals 5. Both of these x's are still equivalent to each other, but that's still not what we wanted. We want to get x by itself. So we know that adding a positive 1 to this equation is not going to get x by itself. But there is a way where we can do that. I want you to think of 1 minus 1 or 1 plus negative 1. If we have 1 and we take 1 away from it, now we have 0. And when we combine those, we can see on our screen that those two are equivalent. So 1 minus 1 is 0. And we want to get x by itself. So if we zero out these ones over here, then it might allow us to get x by itself. Let's see if we can do that. What we call this pairing when we take a positive 1 and a negative 1 and we put them together, we call it a zero pair because its value has 0 and you have a pair of numbers that make a 0 value. So let's try that over here. I'm going to add a negative 1 over here, and what you do to one side, you must do to the other, so we're still equivalent. I'm going to add another 0 pair over here, and another 0 pair over here. And I need to get rid of 1 more over here so I can 0 1 more on the left side of my equation, and the same thing over here. So I have zeroed them out, but I want to physically go ahead and pull it out so we can visually represent it. Before that, let's write down the math of what we've accomplished on our page. What we've accomplished on our page is we have x plus 3, which is our original number. Then we subtracted 3 ones or added 3 negative ones, but I can represent that as just minus 3. And then I have my equals. I have my original 5 positives over here. And we also added 3 negatives or minus 3 over here. Notice that it is also color-coded as red on my page as well. Now let's physically pull these little guys out. So I'm grouping them and I'm just going to pull them off to the side. And same with these little guys right here, these 0 pairs over here as well. I'm going to go ahead and pull them out and just pull them off to the side. And the value of these are going to be 0. That's my 0 corner over here. Now I did break apart my equation by pulling it all out. And then I'm just going to take the little hand and pull it back into the fold. And we can see that, oh, look, it still now has the equivalent value for my x. And when I rewrite this, I can see that x now equals 2, just like we predicted. And of course, it's color coded. Everything on my page is actually color coded all the same color because everything has the same equivalent value. Well, except for these guys over here. Their value is 0. And the last thing that you want to do before we close out this equation is to check to make sure that the value that you identified as x actually is the x you're looking for. Our original equation, x plus 3 equals 5. If we isolate or we scribble out this x and we put the 2 in there because that's what we needed, and we say 2 plus 3 is 5, 5 equals 5.